Great, thank you. So great to be here. Thanks, everybody. I'm really excited to share some of the thoughts that I've had around kind of agentive technology in general. And this is coming from more of a like product manager and human computer interaction standpoint. I'm happy to dive into the more technical aspects of it, but I think like the future of the world will be a mix of kind of people, AI agents, digital twins, and other types of like deterministic systems. And so how do all those things work together is what I want to really talk about today. I have a lot of slides because there's a lot of concepts I want to introduce to you. And then I want to also spend a lot of time just like having a discussion. And so from that perspective, I'm going to kind of give you a lot of signposts for things that you should start to look into. And then I'm happy to talk about kind of any questions you have about those things. And then also deep dive into any of these concepts that seem to be really like resonant for this particular group. So with that, I will share my screen. And so, yeah, I guess like, when we talk about like agents embedded in the real world, I think there's a lot of things that this could mean. And from my perspective, I think it really started with communal computing, and actually it goes a little bit further back, which I'll talk about a certain case study. But when I mean communal computing, what I really mean is I worked on the portal device for Facebook Reality Labs, and this is a device where it sits in your home. It helps you communicate or contact other people, and that's really what it's supposed to be, is kind of a window to other people's homes in a way. Inside of this, though, there's a lot of different technologies that include different types of machine learning. So you could imagine things like voice assistants. The thing that I worked on in particular, I really focused on the idea of identity within the system, like who is actually using it. I focused on things like biometric recognition, which was either like face or voice recognition. And then finally, this idea of just like other assistants that we would include inside of this system in some way. And so I think the thing that was really interesting to me, and I started to realize once I had these systems in my home, is that this was my Spotify made for Chris Butler playlist. But one of these things was actually because the system itself was sitting inside the home in the kitchen. And so my kids would constantly playing like Frozen or other types of like musicals. And so this particular playlist is not made for me. It's actually made for the people that are inside the kitchen whenever they are listening to music. And so what this started to make me think about is the way that we actually start to contextualize information about the people for these devices in the way that they're in the home. And so the question ends up becoming like, are we talking about the kitchen or a particular person? And in this case, it was gathering information, providing it to a recommendation service that was then training or personalizing some type of model, but it wasn't for me anymore, even though it was associated with my account information. And so this is going to get even crazier, right? Like this was from Google I/O in 2022, where these are all the different types of connected devices that are available that will actually integrate with the Google Home type of system. And so there's a lot of stuff here. I mean, I still don't understand what like a connected mop means exactly, but that's fine. So the reason why they're built wrong, and something I want to bring across to you, is that it's all about this fact that like we're still assuming single user context. And I think that's a real issue. And especially once we start to get beyond just like the idea of like a chat one-on-one type of thing. And I'll talk to you about like some experiments that I've done inside of that world. We start to really break a lot of kind of social norms in the way that we understand stuff. So when we talk about agents, I mean, I want to recommend a couple books, by the way. So this is one by Christopher Nocell, and he's at IBM, but this is like really, I think, a quintessential text around the idea of like agentive technology in general. And it's something that I really caught on early on. I mean, Christopher and I kind of connected, not only because we have the same first name, but also because of the fact that there's a lot of stuff around like randomness and the way that we end up having like even more non-determinism inside of our systems, but that's a story for a different day. So I'll share that talk about randomness and decision-making if you're interested. But what he really starts to build out is this kind of like range between things that are fully manual, right? Like, so me as a person, I'm doing this by myself. It starts to then get to assistive, and that could be things like spell checker, things that are kind of like fixing up things for me. we start to get into agentive, which I think is the topic of our talk here, is that it's going to go away. It's like the idea of like delegation. It's going to go off and do something and then come back and check in. And that's where like a lot of the human in the loop type of discussions end up being, is that it's going to try something, it's going to create something, and it's going to check with the human and then either get a yes or no and then move forward. And then there's finally like automation in general, or automatic aspects of this, where something is just going to always happen. So like a cron job type of thing. And there can be non-determinism inside of those systems, but it really ends up being based on the fact that like, I think like what it comes down to is that we're not always including the full set of people that are involved in this, because an automatic system that does not impact humans is actually a system that doesn't matter. And so I want to keep on saying that like everything that we do is about some type of interaction with humans. All of technology ends up being some type of intermediation between people. And so even though we're saying something is automatic, there's still a person that is impacted by this thing. And so I think that's like just one thing I want to bring up. And I've done a bunch of talks about that idea, but I think it's like really important to talk about the spectrum, right? Excuse me. So he has this like loop, which I think is very interesting and definitely something to check out. But it's this idea that like it really, when we talk about human in the loop, like what are the things that are taking place within this world, right? And so there's kind of this almost kind of personification of the agent in the way that an agent would actually interact or involve a human being. And so this was another talk that's really great. I'll link it in some of the resources as well, about like kind of at an MIT conference, we were starting to talk about like the difference between what are machines good at and what are humans good at. And so they brought up a lot of really good points here, which talks more about the idea of like automation. I do want to note that machines do have biases. In fact, the main point of all machine learning, just to be very clear with everybody here, is to create a bias towards something. Like, and we can say, like, again, there's a normative understanding of what is bias, right? Like there can be good, neutral, and bad types of things, but there is always a bias. I just want to be very clear about that. If you train on human information, there will be a bias because humans are biased. If you create something, it will be biased because it's trying to actually make a better decision about something in some way. I saw a hand go up. I'd love to answer a question.
We'll answer the questions at the end.
Oh, okay. All right, cool. Not a problem. All right. And so I kind of, started to create my own list. This idea of like machine learning is actually just a function, right? Is probably the way to think about it. There's a lot of like ability to read everything and then summarize. There's a lot about this idea of like encoding those biases into systems. And then the ideal is that generating content could be extension of what we wanted or considered. And that's where I think there's like a very interesting discussion about the difference between like creativity and hallucination. And I think that's maybe a different talk, but I think there's like a really good conversation about that. And then here's what this same person was saying about what are humans good at. And so context, identifying changing conditions and nuances. And I would go a step further. I think this idea of like, when we talk about decision-making, humans are really good at building off of their intuition and then emotion, which is actually leading them to the right decision in some way. It's also the idea that like we want to take care of other humans most of the time. So this idea of exceptions is something that machines may not be able to codify in a way that is like helpful. And so like actually doing that is something humans are good at. I think this idea of like satisficing, if you have things that are encoded for a machine learning algorithm to actually build recommendations or some type of like algorithm off of, it's not always going to include the N+1 factor that you could have included as a human being. And then finally, like I think humans are very lazy, right? Like we are here to actually put in just enough work to be able to get something done, and machine learning doesn't necessarily understand that. So I think like when we start to then talk about say decision making, and so I'm part of this something called like the Uncertainty Project, which is a community around like decision making and strategy. I've really started to build this like meta model around decision making, and I think there's a lot of things that then machine learning starts to interact with when it comes to the way that we actually make decisions. So even in identification, the idea that you can start to summarize information and maybe start to quantify it using these systems means that you maybe can detect when a decision-making process needs to take place or what type of one. The discourse is usually about creating options, refining them, things like that. And so I think machine learning algorithms can start to help us with not only what are other options that we're not considering, but also how do we refine or start to model these options. The decision point itself, I think, ends up still being a human type of thing. Like there is the case where if, for example, you end up making the same decision over and over again, that's a possibility for either agentive or automatic technology. But before that, I think the human still really needs to be involved a lot. And then finally, like communication is really interesting because the translation from anything to anything type of capability means that every message about a decision can be specific to that person. And then finally, learning is that we can track themes of these things much easier using these types of systems. So like for me, that's where I think agentive technology really starts to be beneficial in some way. And so I want to talk about like a case study that I did. It was probably like in 2017. Like that's a long time ago at this point. And most of the time we were working with PwC and Google for this particular thing. And what this really meant is that field service operations, if people are not familiar, is that like you have a system that you can't take out and then return to the manufacturer when there's a problem and you need something troubleshooted. So this is something that you have to like go on site for. And so in this case, we were working with this company that was doing kind of gas station maintenance and construction. And what's funny is that like these gas stations are kind of more like IT sites than anything because everything's networked nowadays. And so we went and we did a bunch of research to be able to like understand like what is going on there. We're trying to solve problems not only for the people that were field service reps that were out in the world, but also dispatchers and then warehouse people, salespeople. There were a bunch of different people that were involved. And probably the very interesting thing that we started to consider was not only this idea of like maybe prediction about what the problem could be based on a explanation of the problem. We started to then also create systems where an agent could be part of a discussion to be able to provide more information to people. So the idea of like, and we called it Patrick at that point because we were like a little overboard on personification. I still think there's like a lot of issues about that type of thing, and we can talk about that if you want to. But this idea of like Patrick being able to jump in and say, I think this is what the problem is, and then automatically include the most expert person, and then automatically order the right types of parts and start to deal with all the constraint programming with regards to scheduling became very interesting. And so we did a lot of research around like how people felt about this type of thing. Because honestly, again, if we're talking about the fact that like this is all about intermediation between people, we have to understand like, do they believe in this? And this goes back to like another paper I'll reference called it's like Parasuraman from 1996, is this idea of kind of trust in automation and its use, disuse, misuse, and abuse. And so this idea that we have to like calibrate the actual right amount of trust that is into the system in some way. And so we ended up doing a bunch of research. This is an example of where we took a bunch of the research pieces. So we did a bunch of like prototyping and then user research where we pulled out nuggets of information. And then we started to like graph these things on a spectrum or like a 2x2 of the vertical is not understanding what's going on to understanding what's going on. And then the left to right is actually negative sentiment versus positive sentiment. And the thing below the line ended up being kind of things that we just need to do a better job of, either change management, user interface, interpretability, explainability of what the model is actually doing. In the upper right-hand corner, where we're talking about like they understood what was going on and there was positive association, was that it was things that they wanted to actually automate. And the thing in the upper left-hand corner ended up being things that we thought at first people knew what was going on, but they didn't like it. And this felt an awful lot like job security issues, and that's why it's written there as like a tag. But after a couple of years of kind of talking about this experience, I started to come to the feeling that there was a difference between the work that people really valued and found meaning in versus what they really, and the work that they found was like bullshit work, basically. And so I think that's like a very interesting thing when we start to talk about like what jobs should this agent take inside of these like group settings, ends up being the things that are kind of like automaton type of work, not the things that people actually value. And those things up there tended to be things like connecting with customers, actually helping someone, like making someone feel heard. And those are things that humans actually really value a lot. And so I think there's something very interesting about the way we start to consider this. And so this led me then to something called animistic design, which is kind of a weird concept, but it's this idea that it comes from like a spiritual or kind of pagan background where everything has a spirit inside of it. And the reason why human beings did this is because we had to understand the world that we were living in, and we're trying to contextualize not just a rock in this case. So this is a rock in Japan that is considered to have like a spirit inside of it, but it's also just the idea of like, how do we interact with other entities that are maybe non-deterministic? And so this could go all the way to the point of view of like the trickster fox inside of the whole experience around like, say, First Nation people, and Shintoism and a few other religions like start to talk about this. But it's like, how do I understand this thing by partially personifying it in some way? And this was like really inspired by a lot of work by some people, so Jason and a professor at Art Center, Alan, they ended up starting to think about like, how would we do design in a way for these systems that would allow people to personify them enough to understand, but not personify them so much that they have high expectations. And so this is like a very interesting study in the idea of like, what would a municipal hearing at a local government be like if you had people that were not just like council members and local people, like the people that live there, but also like if you had a model that represented like the animals there or the streets. And so this personification allows you to start to interpret things in a different way. So it's all about interpretability. And this is the paper. And he really started to think about this idea of like, rather than this like central authoritative system, how do we start to like provide multiple systems that are inside a system that we actually understand, and we build mental models around that we can understand and interact with in some way. And so he created these like different devices that would sit on your desk. And so, for example, like the Nostalgic would just show you photos of like a couple years ago to try to like spark ideas with you. And so each one of these devices would do something different, but they were non-deterministic in the way that like you wouldn't always understand what they were doing. And so they end up creating a workspace that allowed you to actually do a better job by getting all these inputs in some way. And so I think like this idea ends up being very interesting because inside of the world of communal computing is like, what should a lamp be like? And I'll talk about what I think that means in a second, but I think it's a very interesting question. So it's not just the idea of like, how should a chat GPT be, but it's also, when we start to like put these things in our world, how should our kitchen be? How should the lamp be? How should the device be? These are questions that we can start to ask and actually role play even to think about like what that means. And so this is another case study where I did a workshop at South by that was called "How Does the Roomba Really Feel About Dog Shit?" And what was it about was that this idea that, I don't know if people have seen pictures of this, but like Roombas will, if they find dog poop, will smear it all over the ground. And so, there's some people calling that art. There's some people calling it like, a failure of a system. What's very interesting to me is once we start to think about not just the Roomba, but like all these devices in our world, when we take like an animistic design point of view, we start to consider how might these things want to work. And so this turned into like a role play game, essentially, where everybody chose a particular device. They created a bunch of kind of personification elements, like what makes them happy, what makes them sad, what makes them disgusted. And then I had, and this is like a virtual version of this, so I've run this workshop multiple times. I was in this type of room, and I actually started to give them a role play, which is, there's a bunch of stuff about role play and LARPing that I think is very interesting. So I put them in this like mode where they were pretending to be machines, basically. And I set up a fake household, and then I had everybody come in and pretend to be those devices. And I had people come in and pretend to be humans. Well, they were humans, but they pretended to then interact with a bunch of people. And so the question became like, how should these devices actually work together? And it's not just about the idea of like, how do we then enable the human beings that are here, but what are all the things that we have to do behind the scenes as a set of agents? And so I think this like animistic design gets us into like a prototyping space as well. That's really interesting. And so this is an example of like the workshop we did on Miro versus in the real world. And so this started to like make me think about the idea of like, once we start to have large language models, we can start to create agents inside the system that can work with each other. And I'll talk about a bit more about what that means, but like, this is a prototype I put together, which is like my household. And so you know, the biggest problem with a lot of home automation, especially like intelligent systems, is that usually these rules are very brittle. It's because I have to set up something that's based on day of week, hour of day, and certain types of like turning on and off automatically, or some type of like sensor system. But the reality is I want it to be more intelligent than that. So like even though if I walk into a room, I don't want it to just turn on the light, right? Like I want it to actually be aware of who's in the room before they turn on the light in some way. And we also don't want like it to be like Beauty and the Beast, where every device sings at us. So there's like some type of balance here about the way that we do things. And in the end, by the way, like the Roomba, the person who played the Roomba was terrified of the dog poop. So they didn't want to deal with it. They wanted to notify the human being and then tell them to take care of it because they didn't have the tools to actually deal with that in some way. And so this takes me to like agent ecosystems in general. And just to kind of like, I think, give one final set of provocations before we start this discussion. I think like a lot of people think about these types of systems as that you're putting in some type of input and you're getting an output. And that could be a prompt and you're getting out an image, any of those things. Well, the reality is it's more like you're putting in a prompt and there's a bunch of models that actually exist to then clarify, simplify, and sometimes just outright reject the prompt that you're actually using. Then it goes to these large language models. And then finally, when we talk about the output, there's also screening that starts to happen. And so we're already talking about multi-agent systems. They just tend to be serialized. So even things with like LangChain, right? Like the reason why that was so interesting and popular was because of the fact that like we could actually start to create serial versions of these types of things. And so this is a really great paper about the idea of like the way that we start to chain these things. And I just want to like drive the point home that it's not all about just one model. It's all about this fact that like for all those things that are input filters, system prompt, output control, output filters, those are all potentially models or deterministic systems that end up doing training in some way. And so this led to a paper that came out of Google called Socratic Models, which I think is really interesting. And it talks about this idea that like human language is one thing that we can use to then be an interface point between these models. And so kind of like I was talking about that idea, the provocation of a home where all the devices are talking together, this is that type of thing. Except we're talking about chaining different types of models or having them react in like a shared space. Now the problem is, right, and this is another paper about the idea of like chaining these systems in some way, is that if you have some type of like actual accuracy of like 80% to the use, and you do that through this entire chain, what you end up getting is actually a below 50% kind of accuracy here. And so what I want to talk about is like maybe some ways for us to understand this and to do a better job and build guardrails around that. And so this is something that came out of the People Plus AI guidebook. Before I left Google, I was helping contribute to this from a product manager perspective. But this idea of like looking at critical moments for each of those models and then creating guardrails for what we do want the person to ask for and for the model to do. Things we don't want the person to do and we want the model to not do. This idea of kind of like failure cases that are okay, and then finally like harm that can happen through vulnerabilities. We end up building a much better model that for each one of those stages, we're actually building composable modules that can be working together. But the idea of the interface ends up being the really important part. And so I guess like in closing, right, and I want to have a discussion right now, is my favorite quote from Alan Turing, which is that if a machine is expected to be infallible, it cannot also be intelligent. So the question becomes, what is acceptable failure cases inside of our worlds? How do we actually link up different agent models between those different things? And then how do we end up building systems that are not doing harm to people in some way? And so